Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good day to everyone. So today Group 6 will be presenting the application of AI in ports, shipping and inland. The group mate today will be Hazrien, Mas Damia, Nurul, Fatihah, Najwa, Putri, Balqis and Ariff. Also including me, Muhammad Iqbal bin Muhammad Ariff.
Hello, my name is Fashahira Binti Puad. I will present the abstract for the title, The Application of AI in Port, Shipping and Land. The research is about focusing on its functionality, capabilities and evaluates AI effectiveness in data processing, forecasting, cargo loading, unloading, and inland operation, highlighting innovation and sustainability. The research for this application is through the bibliometry analysis. It refers to the set of articles that uh, analyze organic information and citation link visualized through a VOS viewer software. Authors and papers that vary in size based on the number of citations are presented with the node in citation network, delivering information about driving AI advancement in maritime sector. The writer of the article are cluster of collaboration exhibiting diversity themes in subjects like innovative maritime network frameworks, energy efficiency, and environmental management in port area. 225 225 items were found to be organized into 60 clusters by a keyword concurrence analysis, showing correlation between terms such as artificial intelligence, machine learning, decision support system, and big data. 8 items in collaborative cluster with 28 links by a co-authorship analysis are showing insight for dynamic structure of institute and international research in this field. Keywords for this paper are artificial intelligence, maritime sector, bibliometry analysis, machine learning, sustainability, and VOS viewer.
So for introduction, what is maritime industry in the past and the present? So maritime have a significant role in the country economy, and maritime is used to providing food, world exploration and also cross-cultural exchange. Shipping and port management have sophisticated and methodological process and manage dozens of ships simultaneously at a time. Example of past port including Piraeus in ancient Greece and ancient Egypt's port. As you can see, the volume of container and container ships can handle in units of TEU. In the 1980s is almost 36 million TEUs, but nowadays it is reaching almost and already exceeding 545 million TEUs. So with that said, we can see how technology nowadays can break and make the maritime industry. So the issue now is the constant explosion of ICT have given rise to e-commerce and industrial 4.0, Industrial Revolution 4.0, or as we know it as IR 4.0. There is a good effect and a bad effect for it. For the bad effect is the demands for supply increase significantly, as it is because more items need to be shipped from supplier to end user. And as an effect or a conclusion, a better, more efficient management must be implemented in port and shipping. While we can see the good effect from IR 4.0, and it is AI was introduced and is used in many sectors such as agriculture, health and education. The uses of AI commonly to handle big data such as a huge amount of inputs of data and accurately simulate situations. In the conclusion, we can say AI would be a great addition to aid and help the port and shipping management. So let's see here how artificial intelligence, or as in short AI, does helps. So the problem we face in our port and shipping is human cannot handle huge amount of input without mistakes. If they handle all those small inputs, they will make mistakes and fault. This will lead to an error and unclean or like unnormalized data. Other than that, the problem faced is the delay of operation can set off a chain reaction delaying at the operation. This is because if one ship is observed to be delayed and is not properly managed, it can really affect the other ship that would come in and out of a port at a time. The last problem that we have listed is the precise decision must be made in a short amount of time. Precise decision is a must because, as we know, if there is a delay and a decision is not made in time, it will set a chain of reaction, just like how this problem affected or related to the previous problem. So what can AI do? AI can handle huge amount of data. AI can forecast ship movement. AI can better risk management, and AI can optimize operation. So by handling huge amount of data, it can convert the data into a more digestible interfaces for the human to read and understand. While forecast ship movement can help with the in and out of the ships. How can AI help in better risk management? AI can predict the problem and simulate the situation that is given, and it can offer solution in second. Optimizing operation, AI can really do that because it can definitely see the pattern, and its resources will be used efficiently and nothing will be underutilized or overutilized. So after some explanation on the maritime industry of the past and the present, and some explanation on what AI have done and what AI could be, we beg the question, how can AI be implemented appropriately in the maritime industry? And from all of the explanation, we have listed the objective such as follows: to study the function of artificial intelligence and its capabilities toward maritime industry as a whole, to inquire AI's capability to manage ship navigation and forecast the arrival and departure at ports, to investigate the AI's potential in managing cargo's movement in loading and unloading at the port, to seek the AI functionality in helping at last mile delivery and inland operation, to evaluate AI's capability in handling large amount of data efficiently with digestible interfaces.
I will be presenting on the use of artificial intelligence or AI in logistics. AI has proven to be a powerful tool in maritime logistics, port management, shipping operation, and land transport. It helps address inefficiency by automating repetitive tasks, optimizing routine, and predicting such as maintenance and demand. AI also processes massive amounts of data in real time, enabling logistics systems to adapt quickly and avoid delay. However, the adoption of AI in logistics faces challenges such as high cost, integration issue, regulatory mandates. Next, there are several key theories and models that support the application of AI in logistics. First, theory of automation. Automation is a key feature of AI, replacing human tasks to improve efficiency. For example, ports like Rotterdam and Singapore use AI to automate cargo handling and crane operation. This reduces human error, optimize resource, and increase the number of shipments handled without requiring expensive infrastructure. Next is machine learning predictive analytics, demand forecasting, fleet management, and maintenance prediction. Next, risk management model. AI use model like Bayesian network and STPA for safety in autonomous systems. Last, cybersecurity framework. As logistics become more connected, cybersecurity is critical. AI help detect and prevent cyber threats in real time, protecting critical systems and operations. Next is trend and application. First of all is AI import. AI transform port operation by automating crane scheduling and traffic management. Port like Rotterdam use AI to reduce congestion and downtime through predictive tools. However, high cost, system integration issue, and skill shortage limit adoption, especially in developing regions. Next is AI in shipping. AI optimizes fuel use, routes, and navigation in shipping, enabling safer and more efficient operation. Autonomous ships rely on AI for real-time decisions like collision avoidance. For key challenges include the lack of global standard and ensuring reliable data. Lastly, AI in land logistics. AI enhance land logistics through better routing, fleet management, and demand forecasting. Companies like DHL and Amazon use AI to improve delivery and reduce costs. Challenges include high costs, system integration, and data privacy concerns. Despite the advancement in AI, there are still research gaps in this field. First, risk management. There is limited research on how AI can predict and manage risks such as destruction caused by cyber attack or natural disasters. Second, integration with blockchain and IoT. Combining AI with technologies like blockchain and IoT could revolutionize logistics by ensuring secure and transparent data sharing. However, research on this integration is still rare. Next, regulatory and ethical challenge. The lack of standard framework for AI logistics creates challenges related to data privacy, transparent and accountability. Addressing this issue is crucial for wider adoption of AI in the industry. The last part for the literature review is a conclusion. AI is transforming logistics across port, shipping and land transport by improving efficiency, reducing costs and promoting sustainability. However, challenges like integration costs, data reliability and regulatory hurdles limit its adoption. To unlock AI full potential, research must focus on areas such as risk management, AI integration with blockchain and IoT, and ethical framework. By addressing this gap, we can ensure that AI is implemented smoothly and effectively, paving the way for a more efficient and sustainability industry.
To get the data for this research, we use bibliometric analysis for the methodology. It is an organized analysis of scientific literature done to find trends, patterns, and effects in a certain topic. Large volumes of scientific data can be thoroughly examined and evaluated using bibliometric analysis, a method that is ideal for this study. The Scopus database was used to obtain the data for this study, and the keywords used to search for this data are artificial intelligence in ports, artificial intelligence in shipping, and artificial intelligence in inland. The time range for the search is also set from 2013 to 2024. The bibliometric analysis was conducted with the first technique, which is citation analysis. Citation analysis is used to identify highly cited papers and authors, revealing influential works in the field. Next technique is keyword co-occurrence analysis. Keywords from the articles were analyzed to detect trends and emerging topics in AI applications in the port and shipping industry. Co-authorship analysis is used to observe the collaboration networks among the authors to identify active research groups contributing to this field. All these analyzations were visualized using VOS Viewer as the main tool.
The bibliometric analysis of the application of artificial intelligence in ports, shipping, and inland logistics provides key insights into the state of research, major contributors, collaboration patterns, and dominant themes in this field. Citation analysis is a bibliometric method used to identify the most significant papers and authors in the research area of AI applications in the shipping industry. Using VOS Viewer software, we developed a citation network as shown in the figure. This network includes 101 items grouped into 28 clusters with a total of 183 citation links between them. Each node in the network represents either an author or a paper, and the size of the node corresponds to the number of citations it has received. Larger notes signify more influential authors or papers. The links between notes indicate citation relationships, with thicker links showing stronger citation connections. The clusters in the network are differentiated by color, and each cluster represents a group of authors or papers with similar citation patterns, often reflecting common research topics or methodologies. This analysis highlights some of the most influential works and contributors in the field of AI technology applications in ports, shipping, and inland. Notable researchers include Abid Azhar and Mahdi Jassim, whose collaborative work focuses on AI-driven optimization of thermal energy storage systems. Their study emphasizes the role of AI in improving energy efficiency by analyzing parameters such as PCM inlet pressure and port geometry. Similarly, Askinis Dimitris and Sapelas Kianis have made significant contributions with their work on the Vessel AI framework, which uses AI to optimize maritime processes through innovative case studies and practical applications in shipping operations. Another prominent research team, led by John Hyungjin and Choi Il-hwan, has focused on integrating AI with environmental models to predict and reduce air pollution in port areas such as around Busan Port in Korea. These examples underscore the diverse applications of AI in the maritime and shipping industries. From energy optimization and process improvement to environmental sustainability, AI is driving innovation across various domains. The clustering patterns in the citation network also reveal the collaborative and thematic connections shaping the research landscape, highlighting how shared interests and methodologies bring researchers together to address key challenges in the field. Keywords serve as concise summaries of papers' main content, and bibliometric analysis through keywords helps identify major research clusters in the field of AI applications in shipping. Using VOS Viewer software, we developed an author keyword co-occurrence network as shown in the figure. This network consists of 225 items grouped into 16 clusters with 1,953 links and a total link strength of 2007. Each item in the network represents a keyword, and the size of the area reflects its frequency of occurrence. When two keywords appear together, it signifies co-occurrence, and the distance between keywords indicates the strength of their relationship. Smaller distances represent closer associations, while clusters of the same color signify closely linked keywords. Keywords in different colors belong to different clusters, and the connections between keywords are represented by lines, with thicker lines showing stronger relationship. The keyword co-occurrence analysis highlights key emerging topics in AI applications for ports, shipping, and inland. The analysis revealed clusters centered around principal terms such as artificial intelligence, machine learning, decision support system, and big data. These keywords reflect the growing interest in using AI for predictive analytics, optimization, and decision making in the maritime sector. Other terms, such as forecasting and AIoT, represent more practical and technological developments being actively explored. This analysis not only identifies the key themes driving research, but also emphasizes the evolving role of AI in enhancing efficiency in decision making across the shipping and port industries. Co-authorship analysis is a method used to explore collaboration networks among researchers and institutions. It highlights how scholars work together and helps identify active research groups contributing to a particular field of study. Using VOS Viewer software, we created the co-authorship network shown in the figure. This network consists of 8 items grouped into a single cluster with 28 links connecting them. Each node in the network represents an author, and the size of the node reflects the number of publications associated with that author. The edges indicate co-authored works, and thicker edges represent stronger collaborations based on the number of shared publications. Different colors in the network represent clusters of researchers who often collaborate, typically influenced by geographical areas, institutions, or shared research interests. This co-authorship network reveals the structure of collaboration in the field of AI technology applications for port, shipping, and inland operations. It provides valuable insights into the dynamics of collaboration, identifying key authors and institutions driving innovation in the field. For instance, Abid Azhar and Mahdi Jassim have collaborated on a study using a dynamic melting method to improve phase change material-based thermal energy storage systems. Their research explores optimization parameters such as PCM, port geometry, and positioning, employing neural networks to identify optimal configurations. The findings show significant advancement in PCM melting time by modifying inlet diameters and pressures, bridging thermal energy advancements and AI techniques in the context of renewable energy storage within port and shipping operations. This co-authorship analysis underscores the growing international and institutional collaboration in advancing AI applications for maritime operations. Clusters of closely linked researchers like Abed Azhar and Mahdi Jassim represent active research hubs driving innovation. The visualization also highlights geographic and institutional patterns, showing how researchers from different regions or institutions often collaborate on similar topics, fostering cross-border knowledge exchange.
Alright, so I'm gonna present about the discussion for our report. Okay, first we look at that for research insights. So citation analysis brings out the prominent role of certain researchers like Abid Azhar M, Mahdi Jassim, Asconi's Mysteries, and Jeong Hyung Jin, which is they are contribute to AI based energy optimization, process enhancement, and environmental management. Uh, so this is for to increase this trend worldwide of using AI for energy efficiency efficiency improvements, operational betterment, and sustainability in maritime operation. Okay, we look also for the clustering patterns, which is clustering reveals fragmented but interconnected subfields in maritime AI research. Alright, next we look for keyword trends, which is the dominant themes for this is are artificial intelligence, which is AI, machine learning, big data, decision support system. So these are indicative of the current need in the sector towards predictive analytics and optimization and also decision making tools which is will use AI. Okay. Emerging keywords such as AIoT, which is artificial intelligence of things, and forecasting further highlight the marriage of AI and advanced technologies in addressing complex. So forecasting for operation and logistic advancement. Okay. Alright. Third, collaborative dynamics, which is international and interdisciplinary partnerships enhance innovation. For example, in the works of Abed Azhar M and Mahdi Jassim M, um, regarding dynamic mathematics, it demonstrates that AI research in energy system as well as AI techniques has an interdisciplinary character from their work. So this dynamic of collaboration actually strengthen multifaceted challenge within the sector to achieve a common goal of innovation at a global level in maritime logistics. Okay, next we look at for implications, which is for practical. Okay, we look at for practical first. So AI drives energy efficiency cost reduction, and operational improvement. For example, neural networks optimize thermal energy storage, okay, which has disease can gain energy and eventually reduce operational costs and environmental tolls. Okay, similarly, AI enable frameworks for maritime process such as missile AI would, would yield information for improved operational efficiency as well as decision making. Okay, next we look at for implication for policy, which is impressive the need for collaborative and sustainability focused AI policies. Okay. Mm, yes. Alright. Next, we look at for future research direction. So the studies needs to highlight this, which is uh, we need to address that AI's role in many things. For example, AI's roles in safety, risk management, and socioeconomic impacts. This is for encompassing understanding of AI's potential. Alright, next, second, um, we need to expand international collaboration networks. This is for global maritime innovation. So these two things actually can give more benefits for maritime community and also for our country.
For application of AI in port. AI is changing how port work by automating tasks like container handling, crane operation, and inventory management. This reduces the need for manpower and lower costs. AI-powered vehicles make terminal operation faster and safer. Ports like Rotterdam use AI for real-time monitoring and better decision making, while predictive maintenance has cut downtime by 25% at the Port of Hamburg. Recent studies show that AI is driving advancement in automation, sustainability, and innovation in maritime logistics. In conclusion, AI has the power to transform port operation for making them more efficient, reliable, and ready for future.
For the application of AI in shipping, the AI application in shipping can transform the operations, efficiency, and sustainability of fuel usage and navigation. Artificial intelligence can analyze amount of real-time data, enable ships to adjust their routes based on a few factors such as weather condition, traffic pattern, and ocean current state with the advanced algorithm. This factor can reduce fuel consumption and minimizing the risk of collision with real-time decision making. The integration of AI in shipping operation show a shift towards smarter logistics that consider economics and ecology to a more sustainable maritime industry. Alright, we look for AI application in inland logistics. Okay, this is for the part 3 lah. So first, navigation system, where AI contribute in navigation system for ensure safe, efficient routes using sensors and algorithms like physiology. Alright, so AI also contribute for cargo management, which is with AI can monitor storage conditions to prevent spoilage and also transport risks. Okay, third, AI also contribute in energy management, where AI dynamically optimize energy usage reducing costs and also emissions. Right. Fourth, AI also contribute in autonomous operations where AI just remote control and also autonomous system easily can enhance navigation and also reduce human intervention. Alright, also the last one we look for development development timeline for AI, which is okay. As we know, inland logistics is integrating AI. So this is in phase development, still in phase development. So initial efforts are being directed toward modular intelligence system, including navigation and cargo management. So which is these are expected to reach maturity around 2030, and by 2050, fully autonomous system would have taken over the market. So this is uh, by of continuous development in other technology is supporting such as IoT, big data, and also cloud computing. So this progress actually show to us um, the ability of AI to make inland logistics systems smarter, safer, and more sustainability. Right.
In conclusion, the application of AI in port, shipping, and land logistics is driving significant advancement by addressing inefficiencies and introducing predictive capability. AI enhances port operation through automation and real-time forecasting, reducing congestion and optimizing processes in smart ports like Rotterdam and Singapore. In shipping, AI-powered systems improve navigation, route optimization, and promote environmental sustainability and operational effectiveness. AI logistics on land streamline last mile delivery by optimized fleet usage and ensure reliable service to meet the demand of e-commerce giants like DHL and Amazon. However, the adoption of AI faces challenges including high implementation costs, integration complexities, and regulatory gaps. Research limitations such as the need to integrate AI with blockchain and IoT strengthening cybersecurity framework must be addressed. Bibliometric analysis highlight AI transformative potential in themes like sustainability and decision support system, while collaborative network underscore its promising advancement in maritime technologies. Overcoming this obstacle and closing research gap will enable AI to fully revolutionize logistics and to ensure sustainable and efficient solution for the evolving global economy.